All right, your books are open to page 18. For homework this weekend, you did numbers 1 through 8 and 12. We'll go ahead and take a look at that together. And Kendall, hopefully you get feeling better soon. And hopefully you're able to keep up at least somewhat with what we're doing. And then Brecken and Gavin, good to have you joining us as well. Page 18, numbers 1 through 8. First of all, you were dividing by a monomial. 3 steps to divide by a monomial, class. Sign, number, letter. 3 steps to divide by a monomial, class. Those 3 steps are?
Sign, number, letter.
If the signs are the same, you get a?
Positive.
If the signs are different, you get a?
Negative.
Number. You just divide. Unless you can't. What do you do if you can't divide, Abby?
A number.
Yeah, if you can't divide the numbers, what should you do? Noah. Reduce the fraction. Again, we're going to write these as fractions. So, for instance, you can't divide 4 by 10, but you could reduce it down to a 2/5, for instance. And then with the letters, we said to divide like basis, class, we subtract the exponents. And remember, we said that if the bigger power is on the bottom, still subtract. You just leave the answer on the bottom, and we'll have a denominator present. Let's see how we did on these. And only one of these ended up with a fraction at all. Number 1, what was your answer, Audrey? Good, 4x, positive 2. Number 2, Genesis.
I got stuck on this one.
Got stuck on that one.
I got 3x squared plus 2.
3x squared, positive 2. Let's take a look at it very quickly, Genesis. We have a 9x cubed, positive 6x, all being divided by a 3x. And again, the key here is when you do your division, do it twice. So we're going to ignore the existence of the 6x and just divide. Sign, number, letters. All right, then we're going to ignore the existence of this and just divide here. Sign, number, letter, cancel. And there's my answer, right? So just really quick and easy doing the sign, number, letter. Just being careful with those little details. Back to number 3, Genesis, your answer.
5q cubed plus 3q plus 2.
Oh, one little tiny edit there, Noah.
5q cubed positive 3q negative 2.
Negative 2 at the end, because the signs were different. So 5q cubed, positive 3q, negative 2. Third tries the charm. Genesis number 4.
4y cubed plus 3y minus 1.
There we go. 4y cubed, positive 3y, negative 1. Number 5, Michael.
Negative 16k to the 4th, negative 6k squared, and either 3k over 4 or 3 over 4.
Positive 3 over 4. Let's take a look at that real quick. At the very beginning, you had a 16k to the 6th. It was being divided by the negative 4k squared. You remembered the letter, but you forgot about sign, number. So what's the sign?
Squared.
Sign. Positive or negative?
Negative.
Negative number?
4.
And then the letter is a k to the 4th. Your middle was correct, where you divided to get the negative 6k squared. And then at the very end, we had the negative 3k squared. Again, sign.
Positive.
3 can't divide by 4, so as we said earlier, reduce the fraction. Well, it doesn't even reduce, it just stays 3/4, and then the k squareds will
Disappear.
because they, what's the word, class?
Cancel.
Cancel. They cancel each other away. Or you could say k to the 0, but we don't want to waste our time writing that down. Number 6, Maddie.
Negative 5x to the 10th.
10.
Positive 3x to the 6th. Negative 11x to the 4th.
That is correct. I can't tell if you did that on purpose or not. Negative 5x to the 10th, positive 3x to the 6th, negative 11x to the 4th. Number 7, Abby.
2c squared d, negative 4cd plus 1.
There we go. 2c squared d, negative 4cd, positive 1. And then number 8, back to Noah.
7 p to the 7th, w to the 6th, z to the 4th, positive 3, p, w to the 4th, z, negative 2,
Really close. Only one tiny edit. What should the edit be, Brandon?
it will be a plus 4.
Positive 4 in the middle term. 28 divided by 7 is 4, not 3. But otherwise correct. 7, p to the 7th, w to the 6th, z to the 4th, positive 4, p, w to the 4th, z, negative 2w, our answer for number 8. Did anyone go 8 for 8? Okay, only a couple of you. 7 for 8, you just missed 1. Again, a lot of little things in there to miss. 6 for 8, just missed 2. All right, on one or ones we missed, do we understand them now? Any questions at all? Let's take a look at number 12, where we had a long division problem. Let me go ahead and drag the camera over there to get the poster in. And this is what we'll use, this division house, remember. And anytime we divide by a polynomial, even if it were written like a fraction, and it wasn't, right? It said divide blah, 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 by a squared plus 1. But even if it were written in fraction form, we would still take the time to set up the division house and put our divisor outside. However, I said when we divide, it's ideal that we would have no missing powers. So when we write down our a squared plus 1, notice that goes from an a squared, the second power of a, to the 1 where it's an a to the 0. So rather than skip over the a to the first, I recommended you put something in the gap. What was it, Maddie?
0.
There we go, positive 0a, or a 0a to the first if you wanted to write the exponent. I don't, but a 0a. I technically added nothing. That's what that is, right? Nothing, 0, zilch. But it holds the place so things will line up better. And then as far as the dividend here, it's all out of order. Again, we want descending order. How should we rearrange the dividend here? Genesis? On number 12. There we go. We just really had to move that a cubed up a little bit and get it in descending order. How many did copy the problem down just like this? All right. Any questions on the copying? All right, then from there, we go through our steps. Now again, the poster doesn't have everything I want you to say, but it'll help jog your memory. My first step is to do what, Audrey? Divide the first by the first. It's a to the fourth divided by a squared. Of course, we know when we divide like bases, class, we subtract the exponent. So, Audrey, when I divide, I get? A squared. I'm going to write it down. Then my next step, Genesis, is to multiply by the entire divisor. Or there was another word I told you to write down in your notes. Anyone? Distribute. When you multiply, you're distributing to everybody. I don't remember it was Kendall I picked on, right? With the candy, I distributed the candy. Of course it was Kendall I picked on. I love you, Kendall. I hope you get better soon. All right, so we're going to distribute the a squared. And what do we get, Genesis, when we distribute the a squared through the divisor? 0 a cubed. Sign number letter. Don't forget the number, and it is a 0. Good. I'm going to go ahead and write the 1a squared here as well, just so I remember it is a 1 as opposed to the 0 we see here. Then my next step, Brandon.
Subtract, but you have to switch the positive.
Yeah, what do we call that, class? Adding the inverse, right? So we're going to add the inverse here. The poster says subtract because I'm lazy and I didn't want to write add the inverse. All right, I'll make you write it, but I don't write it because I'm a teacher. All right, and of course the first terms when we subtract, Brandon, always cancel. Then from here we got a 3a cubed negative 0a cubed.
Positive 3 cubed.
And then we've got a 5a squared and negative 1a squared.
Positive 4a.
All right, and then our next step, Michael, is to bring down so that we have the same number of terms here as we have up here. Well, I've got 3 terms here. I need to bring down 1 more to give me 3 here. And then it's back to the beginning again where we once again
Divide the first by the first.
And when I divide, this is now my first term. Everything else is canceled. So the first by the first I get
3a.
Positive 3a. We write that down and then know what we need to distribute. Multiply. What do we get when we distribute? A cubed. And then, Maddie, I need to add the inverse. Change all the signs. And, of course, the 3a cubes will cancel. 4a squared negative 0a squared. And 3a negative 3a. Ooh, that cancels as well. And so when I bring down my 4, we see this gap. Let's go ahead and leave the 0a in the gap. Does that make sense? Rather than leaving the gap. And then we go back to the beginning again, where once again, Abby, we
Multiply the first by, divide the first by the first.
divide the first by the first. The 4a squared divided by a squared just gives us 4. And we can kind of see here as we multiply, Abby, 4 times all of this is going to exactly equal that. And when we add the inverse, it'll all cancel. If we want to take the time to show this step, we certainly could, but I also think that for the most part, once we see that, we can kind of finish up. Now, there wasn't a remainder, but let's suppose this had been a 9 instead of a 4. Well, then there would have been a remainder here, Abby, because 9 minus 4 gives us
5.
a positive 5. Well, if we have a remainder, how do I write the remainder, Brandon?
And the fraction.
As a fraction, specifically if this were the remainder. It wasn't. This was our answer for 12. How many got that answer, by the way? Okay, only a few of you, okay? Those who didn't get it, questions before we go monkeying with the problem? All right, let's monkey. Brandon, speaking of monkey, Brandon, he said he wanted an example of picking. He's like, do you pick on people? Can you give me an example? So I'm giving him an example. I'm just trying to help out, it's the teacher in me. Anyway, Brandon, if there were a remainder, you said we'd write it as a fraction. Specifically, what would it be here?
5 over a squared. Oh, a squared plus 1.
Good, and we don't need to write that because we don't need a placeholder there. So I like the lazy man approach of a squared plus 1. Don't forget the sign will go in front of the fraction to separate the fraction from the previous number if there had been a remainder. Questions on that part? Any questions on this? Number 11 at your seats now. Take a moment now that we've refreshed our memory on this polynomial division. Work number 11 there at your seats. There at the bottom of page 18. And then, we get a little bit more practice. Then I get to teach you shortcuts. That's what I'm really excited about today, is teaching you the shortcuts. There are 2 of them I want to get to. We'll see if we have time. You work fast. I'll talk fast. You listen fast. We'll get to shortcuts. A couple people already finished. Check your answer. How many got this for your answer? All right. Those who didn't finish or did not get the answer, did you find where your mistake happened? Were you able to find your mistake? All right, let me take a look at yours real quick and see if I can help you locate the mistake. Right here, you didn't add the inverse. I knew you copied it down, right? It's an x plus 1. That's why. You did add the inverse, but you had the wrong problem copied down to begin with. So that would explain that. And then looks like we are on the right track there. Good. So you just finish out with the last step of multiplying by the 3 and you're good to go. Okay. Excellent questions on that. Write this one down now. Outside the division house, I want you to put AM minus 1. AM negative 1. Inside the division house, a squared m to the 4th, negative 4 am cubed, positive 3 m squared. This is a little bit different than anything we saw last year in Algebra 1, or 2 years ago for some of you, where we have a double letter. Here's the key. If you have a double letter, both of them in the first term, we want those letters both to descend. Well, notice A is squared, first, gone. Notice the m is 4th, cubed, squared. Both of them do descend, don't they? So this is descending order, so it's ready for us to multiply, or to divide rather. Go ahead and do the division at your seats. Several people finishing up. And conveniently no remainder. How many have this answer? All right, any questions on this one? Another one for you. Write this one down. In the divisor, C negative 2, and in the dividend, don't copy what I have. C cubed, positive 7c, positive 6, negative 7c squared. But don't copy that down. Fix it before you copy it. How many copied it this way? Excellent, keep working. Don't you wish long division in elementary school had been this easy? It's the same steps. When you're doing it with letters and powers, it just feels easier, doesn't it? Don't have to know your multiplication tables quite as well. And do we get this answer for this problem? Get this answer here. Questions on this? Now, I want you to notice this divisor. Do you see how it's a single variable? No power, no anything, just an ordinary, nice, easy variable. Plus or minus, in this case minus, a nice, easy number. If you have this kind of divisor, which isn't always the case, but let's face it, we've had several that have been like this, you can use something called synthetic division. Next section in your notes. Synthetic division. How many have heard that word synthetic before? Where have you heard it, Audrey? I'm guessing it wasn't in math class. Science, okay, and what was it talking about? You don't remember? Anyone remember what synthetic means? Not necessarily fake, but man-made, but kind of fake, right? Like, it has, for instance, fake cloth, okay? Most of you are wearing fake cloth. Real cloth comes from cotton or wool, sheep and plants, right? But scientists, brainy people, have figured out how to make things like nylon, polyester, right, rayon, and different fabrics made from polymers. They're basically, in a way, kind of like a plastic, but it feels like cloth. It's fake cloth, man-made cloth. Synthetic division is kind of fake division. You actually don't do any division in synthetic division. And it's a shortcut. First thing to write down, anytime your divisor is a variable plus or minus a number. Anytime your divisor is a variable plus or minus a number. Step number 1, make sure you have descending order. Step number 1, you must have descending order in order to use synthetic division. Technically, you pretty much have to use the other kind. I mean, one might argue you don't necessarily have to rearrange it properly per se, but you pretty much do. Okay, so step number 1 gets descending order. For this problem, we done did that. Step number 2, we're going to really mess up division here. You know how a normal division house, you go up and over the top? Yeah, we're going to do everything backwards. We're not going to put a division house on this. We're going to put it on this, but we're going to go down and backwards. I call this a half box. Okay, so you're going to draw a half box, step 2, with the inverse of the number. This is a -2. I'm going to put the inverse, +2. Later on this year, you'll learn why we do that. For now, just do it. I'll teach you the why later. For now, just do it. We're going to put the inverse of the number in the half box. And we're going to copy step 3, the numerical coefficients next to our half box. So we're not going to copy all of this, just 1, -7, +7, and +6. Again, you are only writing the steps down for now. You can watch as I do this, and we'll do several of these together in a moment. But for synthetic division, we don't even bother with letters at all, because after all, letters can confuse us. Letters can mess us up. Let's get rid of it. Then I'm going to draw 2 lines. I'm going to draw an equal sign like we would have in a multiplication problem or an addition problem or subtraction problem. And I'm going to draw a line that sets off the last number. It also sets off a little box thingy here. This is for my remainder, which I really hope is a 0. But I'm going to draw these 2 crisscrossing lines, an equal sign and a line to set off the last number. Next step, we're going to bring down the first number. Just bring it straight down. And you know how normally division hinges on a process of, you do some division, you do some subtraction, but both of those are hard, right? Most of us would agree it's easier to multiply than divide. Most of us would also agree it's easier to add than subtract. Well, guess what synthetic division uses? 2 steps. You alternate multiply and add, multiply and add, multiply and add. So step 4, bring down the first term, comma, then multiply and add. And what do we multiply? You're going to multiply these 2 numbers together. You're going to multiply by the half box. Here, class, 1 times 2, 2. And then we're going to add to get -5. Then we're going to multiply. -10, then we're going to add. -3, then we're going to multiply. Then we're going to add. Oh, yay, a 0 remainder. Well, we already knew we'd get a 0 remainder. Now look at this answer, and look at that answer. Remember how we stripped all the letters out at the beginning? Well, that means our answer is not going to have any letters either. So step number 5 is to put the variables into the answer starting 1 power less. We have a c cubed in the problem. We're going to start with c squared, then c, and then gone. We're going to do a few of these together. Then you're going to do a few of these on your own. So we're going to make sure you understand this really well. But for now, make sure you have the steps copied down so that in your homework tonight, you can do this. So quick recap. Quick recap. Step 1, I got a variable plus or minus a number. Synthetic division. I don't have to do any real division at all. It's fake division. So we're going to draw a backwards, upside down division house and put the inverse of the number. By the way, this is why we don't have to subtract. Remember, subtraction is adding the inverse. Multiply and add. This is how we get away with adding, is by already putting the inverse in there. All right, then we're going to line up our numerical coefficients only. And I draw my crisscross lines. My equal sign, I might set off the remainder line. Bring down the first term, that's multiply, add. Multiply, add. Multiply, add. You really hope for a 0. And then I'm done. So I put in my letters. This starts with c cubed in the problem. So I'm going to do 1 power less. I'm going to start with c squared. And it's just going to straight descend. Squared, first, gone. And there's my answer. Questions on this? Not asking could you do it, but you see what I did at least. All right, let me have you do a couple of these, or really a few of these with me. First problem I want you to copy down. Outside the division house, a positive 3. Notice it is a variable, plus or minus, in this case plus, a number. Inside the division house, for now, 2a cubed plus 2a squared minus 7a plus 15. And as soon as I see that, I say, haha, I am not doing real division. I am doing synthetic division. So I start class by making sure they are in descending order. Thoughts, class? They are. All right, next step. I'm going to draw a little half box. Well, half box. And what goes in the half box, Michael?
The inverse of the numerical number.
The numerical number? The inverse of the number. And what is the inverse of the number, Michael?
-3.
-3. And what do I copy down next to the -3, Abby?
Numerical coefficients.
Which are what?
2 plus 2, -7, +15.
All right, and then in addition, I'm going to go ahead and draw my equal sign and my set off the remainder line. How do I start the ball rolling here, Audrey? Good. Most students don't forget the multiply and add thing, but they'll get started. Wait, what do I do next? Bring it down. Just bring down the first number, which is, of course, class A. And now I do what's 2 steps in succession, class? Multiply and add. Multiply and add. Multiply and add. We just keep going until we're done with the problem. So we multiply, class. And we're going to put that here in the next column, and then we add to get. You're doing this with me. Then we multiply to get +12. And then we add to get +5. And then we multiply to get -15. And then we add to get. Are we happy about that? Yes, we like no remainder. But I'm not actually done with the problem, because my answer isn't 2, -4, +5. There have got to be variables in the answer. How do I put the variables back in, Noah?
Do it like 1 less power.
Okay, so looking at the original problem, Noah, the problem had an a cubed as my starting power. So in my answer, my starting power,
A squared.
a squared. Then in the next term, class, a to the first. And in the next term, a is gone. If I had a remainder, let's suppose this had been a 16. It's a 6. Well, then I have a remainder of +1, don't I? So when I write my remainder, that's +1 over the original divisor, a plus 3. Just like we would have done before, right? The sign goes in front, the number, and then the answer down there. Make sense? Questions on this? Let's do another one. Write this one down. X -3 in the divisor, and x to the 4th, -3x squared, -17x, +x cubed, -30. And Genesis, start us off. Good, put them in descending order. You know what? We're already going to be rewriting this anyway. Let's see if we can cheat the system just a little. Y'all want to do that? Be a little extra lazy? Let's start with the half box, Genesis. And what goes in the half box? A +3. We're not actually going to rewrite them, though you could, but I'm lazy. I'm just going to write the numerical coefficients in the correct order. So the first number I should write down is a 1, because that's my first term. What would be the next term? Another 1 from the x cubed. Then after the x cubed term, I would go to my -3x squared. So I'm going to write down the -3. Then after that, the -17, and then finally the -30. So you see that we don't necessarily have to even rearrange them. We just think through it. Now, if you're like, I would totally mess that up. You know your own weaknesses, right? You know where you may mess something up. So if you need to actually rearrange them, that's not a problem. You do what works for you to be right, to be accurate. Be as lazy as you can, but don't ever sacrifice the right answer. Hey, you have to be right. We like to be lazy. All right, and I'm going to draw a couple lines here. Line there, line there. How do I start the ball rolling here, Brandon?
Bring down the 1.
Bring down the first term, so that 1. And then 2 steps, class.
Multiply.
And then,
Multiply.
and then, and then, I think one more multiply add in there. Anyway, so we're going to multiply, class. 3 right in here. Then we're going to get.
4.
Then we're going to
Multiply.
get.
12.
Then we're going to
9. Oh,
add to get 9. Then we're going to
Multiply.
get.
27.
Then we're going to get. Yeah, good job with the unlike signs there. Then we're going to multiply to get. Then we're going to
0.
add to get
0.
0. Yay, no remainder. We're happy. But I'm not done. I got to put the letters back in. How do I put in the letters, Maddie? So right here, I'm going to put and there's my answer. Questions on this? How many feel like, I think I got this. I think I could do this. Okay, let's do one more. All right. Write your divisor as x +5. And in the house, x to the fourth, negative 3x squared, negative 10. X to the fourth, negative 3x squared, negative 10. You cannot have missing powers. I have missing powers. Again, do you have to actually write them in? You don't have to. If there's more than like one or two of them, you might want to just to make sure you don't miss, you count correctly. But let's set this up. Let's start with our half box class. What goes inside? Negative 5. Volunteer to tell me what numbers to write next to the half box. Brandon.
1, 0, 3, negative 3, and negative 10.
You got the 0x cubed.
Oh, and then another 0.
We also need a 0x to the first. So again, if it helps to write those in, by all means do so. Plus 0, then the minus 10. How many were thinking 1, 0, negative 3, 0, negative 10? All right. Do we see those who weren't thinking that? Does it make sense now? Again, the fun part is if you went from like a 6th power to say a 1st power. How many zeros is that? 5, 4, 3, 2. So it's 4 zeros that have to be figured in. Maybe it helps to write them down. All right, and of course we'll draw our lines. And Genesis.
Bring down the 1.
Bring down the 1. And then what, Genesis? Not yet. Multiply to get. Then to get. Then Audrey. To get. Then to get. Then Abby.
Multiply.
To get.
Negative 120.
Ooh, I thought you had it for a second there.
Hold on.
She'll get it, Brandon. Just be
Negative
quiet.
110.
Negative 110. And then we
Add
to get.
negative 110.
And then Maddie, we to get.
Positive. 550.
There we go, positive 550. And then we Maddie to get
Positive 540.
positive 540. Okay, so we clearly have a remainder this time. But aren't you glad you didn't have to do like the long division with this kind of thing? All right, so what's my answer going to be? Michael.
1x cubed minus 5x squared plus 22x minus 110.
Not 110, just 110.
And, plus 540 over x to plus 5.
And there is my answer. But aren't you glad we got to do it this way? So much easier than doing the long division. Questions on this? All right, we feel like we understand even what to do if there's missing 0 or missing powers. Understand how to work those in. All right, I've got 3 of these for you to work at your seats. Get the first couple up here and then I'll finish erasing and writing them up. All right, first one. X plus 1 is your divisor. And x cubed plus 4x squared plus 5x plus 2. Keep them in work while I write. Once you finish the first two, the answers are on the board. Check your work and see how you did. If you got them, move on. If you didn't, either figure out your mistake or raise your hand and I'll come help you. This is supposed to be next to the fourth, I'm sorry. Actually, the fourth cubed. Wow. I just realized I had two cubes up there?
Yeah.
I'm sorry. Yeah, wow. Because otherwise you would have had to technically combine them and get 7 or 1x cubed minus 1, which, yeah, my bad. Do we see what we should have did if I'd written the problem correctly? All right, we'll just edit that out of the U. No, we can't. Okay. We have to see the mistakes along with the good points. All right. Well, anyway, you got to see the mistakes. All right, questions on this? All right. And then there's this sweet, innocent little guy right here, right? Not so sweet and innocent. I'm getting some shaking of heads. Right, negative 2 is in the half box. What do I write next to the half box, Abby?
1, positive 0, positive 0, positive 0, positive 0, positive 32.
Yeah, because I don't have a fourth, cubed, squared, or first power of x. So there's 4 zeros to fit in the mix. And so, we multiply and add. Be very careful with your signs at this point. And at least there's no remainder, right? And so we end up with the x to the 4th minus 2x cubed plus 4x squared minus 8x plus 16. And there's our answer for those who made it all the way to the end. Did anyone get, other than maybe the third one, unless you figured out what I meant to write, which is always hard to do, how many got at least the first, second, and last ones correct? Did anyone figure out what I was trying to do on the second to last? Nobody figured it out. Nobody figured I meant fourth and then cube.
I thought you were trying to confuse us.
I was not trying to confuse you. I just am human. Hate that sometimes. Questions on this? I want you to notice something real quick here, though. Notice anything interesting about these numbers? 2, 4, 8, 16. They do double. By the way, this is a 1. 2 to the 0, 2 to the 1st, 2 squared, 2 cubed, 2 to the 4th, there's 2 to the 5th. So this was x to the 5th plus 2 to the 5th divided by x plus 2. This brings us to our next shortcut, and this is a fun one. Next section of your notes, division by inspection. What does inspection mean? You look at something. That's inspection. You look at something. Division by inspection literally is you look at the problem, you write down the answer, you're done. That's my kind of division problem right there. It only works when you have a binomial divided by another binomial in which the first binomial, the dividend, if you will, the numerator of the fraction, if you will, has matching powers. So you'd have to have matching powers. For instance, let me rewrite what I had a moment ago. X to the fifth plus 2 to the fifth over x plus 2. Do you see it's a binomial divided by a binomial? And these two powers match each other. You have the x's that match, you have the 2's that match, and you have exponents that match. You can do division by inspection. You can tell you can't use this very often, right? But here's what you can do. If it matches that way, 1 power less, fourth, cubed, squared, first, gone. Gone, 2 to the first, 2 squared, 2 cubed, 2 to the fourth. And you have to memorize this rule, that if you have a sum divided by a sum, and the exponents, these nth powers, are odd, signs alternate. Positive, negative, positive, negative, positive. All I did was write the answer. No math. It doesn't work often, but there are a few rules with the signs. Let's take a look at some of these together. Write this down. Okay, that was an example. This is the first thing I want you to write down. V to the fifth minus Z to the fifth divided by V minus Z. Do you see how these two letters match? See how these two letters match? And those two powers match. Then we can use division by inspection. Now here we have an example, the best example. That's a difference divided by a difference. Subtraction divided by another subtraction. Because all signs are going to be positive. Write down the answer with me. We're going to start by writing in our V. V to the fourth, leave a little space. V cubed, leave a little space. V squared, leave a little space. V, leave a space. I kind of just do a light underline. The V, you notice, is descending, fourth power, third power, squared, first, gone. The Z is going to ascend. Z starts out gone, then Z to the first, Z squared, Z cubed, and then where the other was gone, I finished with a Z to the fourth. You see it? V is 4, 3, 2, 1, gone. Z is gone, 1, 2, 3, 4. And since it's a difference divided by a difference, all my signs are positive. And I'm done. Happens to work out really nicely and easily. Write this one down. V cubed plus Z cubed over V plus Z. You realize this is virtually the same problem? Except this time, we have two sums, not two differences. Make sure I'm still on camera, just barely. If you have two sums, first thing, the exponent has to be odd. If you have a sum divided by a sum, you have to have odd exponents. Notice there's no qualifier on the difference and difference. I could have evens, I could have odds, it doesn't matter. And the signs are always positive. But for a sum and sum, you have to have an odd exponent, I do, and the signs are going to alternate. But the main process of the descending, ascending thing doesn't change. I start 1 power less class, V squared, then V, then gone. Then the Z starts out, gone. Then Z to the first, then Z squared, gone, 1, 2. And the signs are going to alternate. You always lead with a positive. Then, and there's my answer. Make sense? Starting to see the pattern to this. The descending, ascending thing. Write this one down. V to the fourth minus Z to the fourth. V to the fourth minus Z to the fourth. Divided by V plus Z. V to the fourth minus Z to the fourth divided by V plus Z. If you have a difference divided by a sum, the exponent has to be even exponents, and the signs are going to alternate. But I still do the descending, ascending thing. Class, I'm going to start with V cubed, then, and then the Z starts out gone, then Z. And we said the signs are going to alternate, but I said you always start with a positive first term. So then here's my, there's my answer, I'm done. Are you starting to get a feel for this? Now, there is one case that isn't up here. Notice this is 3 cases. Difference, difference always works. Difference, sum, you have to have even powers. And signs are going to alternate. Sum, sum, you have to have odd powers. You notice something's missing? Sum divided by difference never works out evenly. You can never take a sum divided by difference and have it actually work out. These are the only 3 cases we'll use. We can do this with numbers as well, though. Write this down. 8 to the 6th minus 64 all over a plus 2. 8 to the 6th minus 64 all over a plus 2. But notice this isn't written with matching powers, is it? And it's not written with matching numbers, is it? To do division by inspection, I need what number right here, class? 2, and I need what power right here? Thoughts? Should have memorized in Algebra 1, 64 is 2 to the 6th. So, boom. Now, if it didn't work out, if that were not true, then you have to do it the old-fashioned way. You can at least use division by or synthetic division, right? Variable plus or minus number. But it happens, yeah, it is 2 to the 6th. All right? So, class, we start with our 8 to the 5th. I'm running out of room here. All right? And then we're going to start off with the 2 gone, then 2 to the 1st, which is 2, then 2 squared, which is 4, 2 cubed, which is 8, 2 to the 4th, which is 16, 2 to the 5th, which is 32. What about my signs for a difference divided by a sum? And it has to be even. It is. There's 6's. Signs are going to alternate. So I always lead with a positive, which can be understood, by the way, then negative. Boom. Again, faster than synthetic division is the point. Stay with me for just a moment longer. What if we had, write this one down, c cubed plus d to the 6th over c plus d squared. One more, stay with me for a moment. C cubed plus d to the 6th all over c plus d squared. These powers don't match, do they? Oh. But wait a second. This isn't c plus d. It's c plus d squared. And I need a cube. Well, this is d squared cubed, isn't it? Do this with me. C squared, c to the 1st, c gone. It's not a d, it's a d squared. D squared gone, d squared to the 1st, which is d squared, d squared squared, which is d to the 4th. D squared squared. And since it's a sum and sum class, signs alternate. Positive, negative, positive. Questions on this? Homework for this evening. Homework for this evening is to read pages 19 through 23. Read pages 19 through 23. Page 18, number 10. On page 18, do number 10. And do a handout. If you're watching on YouTube, the handout is in the description of the video. So look in the video description. You'll see a link to a handout. I need you to do that handout. It's practicing with synthetic division. Find the link to the handout there. Do the handout. Do page 18, number 10, and read pages 19 through 23. All right, you are dismissed. Have a wonderful rest of your day.